Okay, hello and welcome back to the basic Python course. This is session 3, and today we're going to deal with sequences and mappings. So last week we learned about variables and data types, and I want to make just a brief recap on tuples and lists, which are two of the data types that we got to know. So what are the commonalities and the differences between tuples and lists? You can now briefly pause the video and answer this question if you want to test your knowledge. So what they have in common is that both are sequences. That is, they usually have more than one value, and the elements are arranged in some order. These are the defining criteria for sequences. The difference between them is that lists are mutable, while tuples are not. So this means that the entries of a list can be changed without reassigning the value of this modification back into the variable name. While tuples, if you want to override them, or if you want to change their value, you have to reassign the results of your operation back into the variable name. This is referred to as immutability. Okay, so I'm now switching to my spider in Anaconda. And before we start, I want you to enter the following two variables into your terminal. So we're going to work with this shopping list. And we're going to work with this shopping tuple, which has essentially the same entries. So please make sure that these variables are available to you so that we can work with them during the course of this session. So what we want to learn about first is indexing. So taking out selected elements from a sequence. So what I'm going to show you now works for lists and tuples, but for simplicity, I'm going to show it by applying it to the shopping list, which we have defined. So if we define the number of an item, say 1, and then use this as an index on the shopping list, we're going to get the item in the list whose item number is 1. Please remember that here we are using the Python-based indexing system, which starts at 0. So the first element is referred to as element 0, the second element is referred to as element 1, and so on. Which means that if we call the first item, this is giving us bacon, second item in the list. Okay. Trivially, item numbers or indices must be integers. So if I'm using an index which is not an integer but a float, then we're going to get an error. So, and this is also true if the item number is a float, which could be converted to an integer. So as the error message says, list indices must be integers, so floats do not work even if they are integers. What we can do is, of course, we can convert a float to an integer and then access the list, and this will work and will give us the correct item, which in this case is the third one referred to in Python indexing as element 2. This, for example, makes sense when we want to access an item which is exactly in the middle of a list. Yeah. So if we use len to get the length of our shopping list, then half of that would be n items divided by 2. And this is 3.5, because there are 7 items in the shopping list. And because this is not a whole number, its type will be float. But we can, of course, convert it to an integer. And then use it to access an element in list. Remember that here we are always using square brackets for indexing. And this would give us sausages, which is in fact the middle element in this list. Okay. Interestingly, Python also allows for indexing using negative numbers. So if, for example, we are typing shopping list element -1, this means element 1 counted from the back or from the end of the list, which in other words is the last element in the list. So this gives us gravy mix. On the other hand, if we are typing a number which exceeds the length of the list, then we get an error because obviously the list index is out of range and refers to an item which is not in the list because the list contains fewer elements. We can also get multiple entries from a sequence, such as a list, by slicing. And the way slicing works is as follows. Here we are using the colon notation. So we type shopping list and then square brackets again. And in the square brackets, let's type 1:3. So the idea behind this is that this gives us the elements 1, 2, 3. 1, 2, 3. So let's hit enter to see what happens. Okay, this is interesting. We only get 2 elements, although the idea was that using this notation, 1:3, we should maybe get 3 elements from the list. The reason behind this is that such slices in Python always mean up to, but not including. So the slice here in this index would mean that from shopping list, take the elements starting from element 1 up to, but not including element 3. And this, of course, would be the elements 1 and 2, which in Python-based counting are the second and the third one. So bacon and black pudding. This is a very controversial feature of Python. And one way to maybe understand this is the following visualization. So consider a ruler and some coins that are placed above the ruler. Then we could refer to each of the coins as being positioned above the 0.5 mark of a certain inch or centimeter. And now the slices or the indices in Python indexing refer to the boundaries of the ruler marks. It is the boundary at 0 inch, boundary at 1 inch, boundary at 2 inch, and so on and so forth. So this means that a slice such as 1:2 refers to the space between the boundary 1 and the space and the boundary 3. And what you can see here in the picture is that this space includes exactly the 2 coins element 1 and 2 in Python-based counting, so the second and third element. Another way to maybe understand this is the following example. So if I write down the word Python and then draw a little grid around it, the indices in Python and the indices in the slice that we just used do not correspond to the letters themselves, but they correspond to the boundaries of the grid between the letters. So that means that if we access the elements 1 up to, but not including 3, this should give us the letters YT. We're trying this in a moment. And if we are accessing the elements from 0 to 4, this will give us the first 4 letters of the word Python. If, on the other hand, we are using the index or slice -3:1, this should give us the letters HO. So let's try whether this works. I'm going to define a string called Python, and then my string 1 to 3 would be YT, as we saw. 0 to 4 would be the first 4 letters, and -3 up to -1 would be the letters HO. Yet another way to understand this rather unintuitive indexing system in Python is the following. So consider the floors of the house, which in the English language are usually referred to as the ground floor, the first floor, second floor, third floor, and so on. If you would then access the floors 0 to 2, you could think of those indices as referring to the boundaries between floors, where 0 would correspond to street level, 1 would correspond to the first ceiling, 2 would correspond to the second ceiling of the first floor. And it's clear that if you take the space between street level and the second ceiling, what you get will be the ground floor and the first floor. So this is maybe another way to understand this Python indexing system. So if we are using indices, which are starting at the beginning, we can actually leave out the 0. So we only have to type :3, and this would refer to all the elements in shopping list up to, but not including element 3. And the same is true if we refer to all elements until the end of the list. In this case, we can type 3: as an index or slice, and this would then mean that we access all elements in the shopping list starting from element 3 until the end. So that if you take these two notations together, they would make up the entire shopping list. Okay. Finally, there is something which is called degenerate indices. So we saw that if we are accessing the element 9000, this is not possible. because there's no such element in the list. However, if we enter 9,000 as the upper end of a slice, this works because Python is somewhat forgiving about um, uh, the end in this index of a slice being out of range, and it gives us all the elements starting from element 3 up to the end of the list. Okay, now we want to deal with list comprehensions. What are list comprehensions? So list comprehensions can allow us to perform certain operations for all the elements in a list. Here's one example. Let's say we want to create a new list, which is called item length, and it should include all the lengths of all the elements in shopping list. So the elements in shopping list are words. So the length of this would be the number of letters in each word. So what we could do to construct this list is to just type length shopping list for each item and then always change the index. And this gives us the desired list. Now, this is very tedious and requires a lot of manual editing, and therefore in Python there's a quicker way to achieve this. So you can write the following: item length is equal to square brackets, the length of x for each x in shopping list. Let's see whether these are the same numbers. Okay, this works very well. So here's the general syntax of list comprehensions. First, you take some variable, can be x, but doesn't need to be x. Then you write for x in, and then some list, the elements of which you want to perform an operation on. Then left to the for, you write some operation that you want to apply to the elements of this list. In our case, this was just returning the length of each element in the list. Then you put that in square brackets and submit it to a new list variable name. So this is the general syntax of list comprehensions. As I just said, it doesn't have to be X. So the variable name that you choose for the variable element in the list is absolutely arbitrary. That being said, the same command also works if we replace X by item, in which case the command would read something like, for each item in the shopping list, return the length of each item of this item and collect this into a new list. And this would give the same result. So the variable name that you choose does not matter, but make sure that it is the same here in the for, and then here in the function that you calculate for each item in the list. So list comprehensions are a very useful tool, and they can be used for multiple purposes. Just to give you another example, we can create another list comprehension. Giving us, for example, the starting letter of each item in the shopping list. And then the result of this would not be a list of integers, but a list of characters, which in this case are the starting letters from all the elements in the shopping list. Okay, before we go on to the next topic, mappings, I want to introduce you to one last data type, which is the range data type. So the range, if we call range 0 to 10, this creates a list of all the numbers starting from 0 but up to but not including 10. So intuitively, we might expect this to be, for example, a list or a tuple, that is some sort of sequence, which contains these numbers. But if we ask for the type of this variable, we see that it is a range object. And it gets even worse if we try to print it. Because if we print this variable, 10 numbers, we get exactly what we have entered to calculate it. This is somewhat unfortunate because we would expect this range object, if range stands for all the numbers starting from A up to but not including B, that this variable now contains all the numbers 0, 1, 2, 3 up to 9. But this is not the case. You can access individual elements of the range. So like lists and tuples, range objects are indexable. So the third element in Python-based counting would be the 3, for example. But all the numbers are not explicitly stored under the variable name. What you can do is you can convert this range object into a list by using the list conversion function. And then the variable will actually become a list of integers. So in this case, we will have the 10 numbers that we intended to have when we entered this command above. If that looks a bit paradoxical to you, why do we don't explicitly get the numbers if we enter a command which should produce us those numbers? Then please let me tell you that the range data type can still be useful for creating loops and list comprehensions later on. So what we, for example, can do is we can write for x in range. Remember that with range, this is the same as with indexing. So range 1 to 11 gives us the natural numbers 1 up to, but not including 11, which should be the numbers 1 to 10. And then we use this range object to create a list comprehension. And we write x squared, or x times x, for each x in this range. And this we submit to a new variable name called squares, because these are the squares of the numbers 1 to 10. Let's see where that worked. Okay, fine. I'm sorry, I made a mistake. This should, of course, be x times x and not x to the power of x. And with that, we have the first 10 square numbers. So although the range object kind of hides its context by this vacuous object description and not being explicit about the number it contains, it can be used in a valuable way for iteration and list comprehensions to produce another sequence resting on this range data type. Okay, so with that, we want to get to our next toppings, to our next topic, which is mappings. So for that, I want you to enter the following variable info, into the console. So this is a list. You can also print it to see its context. And this list contains several pieces of information, 3 pieces of information to be precise, which could be the name and the age and um, the place where some person is living. Now, for some reasons, um, the list data type is not the best way to store this information. So there are a few reasons for this. First, the list mixes data types of different kinds. So within this um, list, we have strings and integers, and that may not be such a good idea. Then second, the order of items is somewhat arbitrary. There's no special reason why you first need to put the name and then the age and then the place where the person lives. And third, there's nothing in this list that tells us what these pieces of information are referring to. So it's kind of trivial that the first entry refers to a name, but the second could also be the shoe size rather than the age, for example. And the third one could also be the place of birth rather than the place of living. And um, in such a situation where you want to store labeled information, it may be better and also supply meta information for this labeled data might be a better way to use a mapping instead of a list. And a mapping is defined as a data type in which there are labels, and behind these labels, we have values, which are described by the labels. So in a mapping, labels are mapped to the values which they represent. And the designated data type in Python for defining mappings is the dictionary. So here is the syntax for creating a dictionary. We're gonna now write down the same information as above, but in the form of a dictionary. Okay, I hit enter, and then when I ask for the type, what data type this variable is, I get dict. And as I said, dict stands for dictionary. Now, here is the general syntax for creating dictionaries. You write curly brackets instead of square brackets as they are, for example, used for lists. And then you write some key, which is always a string, and then some value, comma. Then there can be a second key, and the value belonging to the second key, and a third key, and the value belonging to the third key. And this could be your dictionary. So these labels in a Python dictionary are called keys, and the values in a Python dictionary are called values. the whole thing is separated with commas and is enclosed with curly brackets and can then be submitted to some variable name. Now, what are the advantages of storing information in dictionaries rather than lists, for example? Well, one good thing is that we can retrieve the values in the dictionary by referring to their labels. So if I, for example, write info and then square brackets H, observe that I here put H in quotation marks because it's a label referring to some information in this dictionary. I get the H of this person stored in this dictionary. If, on the other hand, I access a label which doesn't exist in this dictionary, I obviously get an error because there's no such key or label in this dictionary. It also doesn't make sense to access the keys through their values. So if I, for example, ask for info USA, which is one value, but not a label in this dictionary, I also get a key error because USA is not a key in this dictionary. Then dictionaries are also not iterable. So if I access the zeros or the first or second element, I get errors because dictionaries other than lists are not sequences. That is, they are not ordered series of information. However, if we type length of this dictionary, we get an answer. So this doesn't tell us that this is a list with 3 entries, as we've seen before. This rather tells us that this is a dictionary which contains 3 key value pairs. Okay, so in the beginning of this lesson, we learned that the difference between tuples and lists is that lists are mutable, while tuples are not. Um, just to remind ourselves of what that means, if we, for example, replace the bacon in the shopping list by organic vegan bacon, this works. And if we want to do the same with the tuple, this doesn't work because the tuple object does not support item assignment, which in other words means it is not mutable. And you have to completely override it in order to change its value. Shopping list, in contrast to this, is so if we is mutable. So if we print the modified shopping list, we see that it now has changed its value. Okay, so how can we find out whether a dictionary is mutable? Well, what we would have to do is access one element in the dictionary, which in this case is a key value pair referred to by its label, and then replace it by another value. And if this doesn't throw us an error, then dictionaries are mutable. So obviously dictionaries are mutable because if we print it, we see that its value has changed without us having to override the whole dictionary. Another question that we might ask ourselves is what kind of methods or functions are available for dictionaries. Remember that we can access all the methods available for a variable by typing dir and then the name of the variable. So this gives us a list of all the methods that are available for this dictionary. Once again, there are a lot of technical methods, starting with these double underscore and adding on and ending on double underscore. Please ignore this for a moment. And then we have some other dictionary methods. And the most important ones that we want to have a look at now are the ones that are here in bold font: items, keys, values, items, and update. So these are the ones which appear interesting to us on first sight. So if we try info and keys, we get the labels of this dictionary, which are name, age, and location. If we, on the other hand, call info values, note that both of these methods don't need input arguments. We get the values behind these labels. If we call info.items, we get another list of pairs, and each pair will be the combination of a label and value stored in this dictionary. And then finally, there is the method update, which works in the following way. So let's say that we have some new info available. For example, the height of a person and the political affiliation. And can print this new info to see what it contains. Okay, that looks all right. And then we can use the method update on our original dictionary with the new dictionary as input. And this will add the key value pairs in the new dictionary to the old dictionary to give us a new dictionary. And as we have just found out, dictionaries are mutable. That is, this command doesn't return a new dictionary, which we can then like store in a new variable, but it immediately operates on the dictionary to which we applied the operation. So no need to type this, and we can just ask for the content of info, and we can now see that these two pieces of information were added to the dictionary. Okay. So when choosing a data representation, you might be wondering whether you should use a list or a tuple or a dictionary. And there's different aspects to consider on what to use. So first of all, when it comes to the question tuple or list, keep in mind that lists are mutable, whereas tuples are not. So you should maybe use tuples for information which does not change throughout the course of your program, such as mathematical or natural constants, which are always the same. And you should use lists for things that can change throughout the course of your program, such as customer data. Then the second question is whether one should use a list or a dictionary. Well, this depends on the type of information that you're storing. If you need meta information and want to make real world connections of of the data which you enter into the variable, you should maybe use dictionaries because dictionaries have keys and lists only have indices. So if you want to refer to elements in a variable through their indices, through their position, you should use lists. If you want to refer to elements in a variable through label information, so keys, strings, then you should maybe rather use dictionaries. Okay, finally, let's have a short look at nested data representations. And here I want to show you an example script. So this script is in lines 9 to 11, creating a dictionary. You can see this here by the fact that it uses curly brackets. This creates a dictionary, and the dictionary has three keys or labels, which are called name, age, and location. And the value of each behind each key in this dictionary is a list. First one is a list of names. Second one is a list of ages. Third one is a list of locations. Now, is it a good idea to store the information in this way? I don't think it's a good idea to store the information in this way, in this particular case, due to the following reason. So let me comment this one here. If I now run the script, I have customers available in my workspace. And if I now change the age of the first customer, or if I want to access this is 22, for example. So customers then using the key age and the element 0 would be the age of the first customer. If I perform the following operation, namely reversing the order of customers in the name key value pairs of the dictionary, this immediately changes the dictionary. And if I then have a look at customers again, I can see that the order of names in the dictionary has changed, but the order of the other variables, age and location, has remained the same. So if you create a dictionary of lists, there's no intrinsic connection between the lists in the different fields of the dictionary. Yeah? So the dictionary doesn't know that the first entry in the list of names, the list of ages, and the list of locations do somehow belong together. And if we therefore perform operations on the individual lists, this does not alter the other lists. So a better way of representing this information would maybe be the following. I'm opening a second example script. run this. So now customers is not a dictionary of lists, but it's a list of dictionaries. So more precisely, we have customers, and customers is a list, and each entry of customers is a dictionary. And now we would refer to the age of the first customer by typing customers 0 and then age. So exactly the other way around. However, if we now perform some operation changing the order of customers, then obviously this affects all pieces of information stored for each customer together. So if we have a look at customers again, we see that the order has changed. They are now starting with Sherlock instead of Mildred. But all the other information has also reversed, precisely because we were using a list of dictionaries. And if we're reversing the lists, all the information in each dictionary is automatically shifted to the new position. So in this case, in this particular case, storing customer information, a list of dictionary is the better data representation. However, there might be cases in which dictionaries of lists might be a good idea. For example, consider this to-do list. If I run this, then I've created a dictionary called to-dos. This dictionary has 3 keys: shopping, chores, and reading. And each value in the dictionary is again a list. But observe 2 things. First, the lists do not have the same number of elements. So here we have 3, here 2, here 3 again. And second, there's no intrinsic connection between the elements of the lists, as we saw in the first case of the customers, where there was in fact such a connection. So if now, for example, we reverse the list of entries in the reading section of the dictionary, this doesn't really hurt because it's being reversed, but this doesn't affect and shouldn't affect the other lists because they have nothing to do with the reading to-do list. Okay, so as a general guidance, I would say choose a data representation um, that makes it hard to do the things that you don't want to happen with your variables. Yeah, so if you are storing customer data, it might be a better idea to have all the information for one customer together, such that if you are performing operations on all customers, this information stores together rather than being torn apart, as we saw happens in the first example. Okay, great. So this is the end of today's session. This concludes our section on sequences and mappings. There are a few exercises again. For exercises 1, A, B, and C, they are not tasked to write a particular script or program, but they are tasked to predict what happens with a few lines of codes if they are run. And for that exercise, please copy these commands into a Python script. And then before running this script, you can copy all of them into one script. And then before running the script, make predictions, what's going to happen with this variable. and what we will see upon running these print commands. Then run your program, and if your predictions were right, good. If they were not right, write another comment trying to explain why the things that happened actually happened. Okay, so that was it. Thank you very much, and I hope you are also enjoying the other videos. Bye bye.